Okay, so example 2, it is similar to the previous one, just the first step is going to be slightly different, but everything else is the same. So let's get going on this one, you guys. So it says, determine how long it'll take for 650 milligrams of a sample of chromium-51, which again, that's just a chemical compound, which has a half-life of about 25 days to decay to 200 milligrams. Okay, so we're going to round our final answer to 1 decimal place. Okay, so the first thing we do, we look for our start amount, okay, which it says determine how long it will take for 650 milligrams of a sample to decay. So this is our start amount, you guys, is 650. So we're actually given it this time. So this time we have a start amount. Okay, if you don't have a start amount, remember this last one didn't tell us how much it started with. It just told us the percent that it decayed to. But if you don't have a start amount, we always just use 1. Okay, but this one had a start amount, so no worries. Okay, so that's our start amount. Okay, it also says find the half-life time, which that is our time on this side. On this side, we always use a different time. So I am looking for the word half-life. Okay, if I see the word half-life, it will give me this time I'm seeking for. Okay, so the time I'm seeking to find is the half-life time, which I've spotted it, half-life right there. And the half-life says half-life of about 25 days. So this is my T sub 1, the time that I'm solving on this side, so time 1. Okay, and then it says our N of T is going to be half of our original amount, which we'll deal with that in just a moment. And then we'll be solving for K. So let's get started. Okay, so N of T is half of our start amount, which our start amount was 650. So to get N of T, we're just going to divide that by 2. So N of T equals 1/2, or 650, divided by 2. Okay, which 650 divided by 2 is 325. Okay, so this is the N of T I will be using. Okay, let's get going. So we have 325 equals our initial amount, which we said was 650, times E. Okay, I don't know K, that's what I'm solving for, so negative K times my T, which we said the T we're using on this side is the 25 days. Holy hot dog, you guys. Okay, so let's start solving this bad boy for K. So now we gotta solve for K. Alright, so if we're gonna solve for K, the first thing, we gotta get our exponential by itself, which currently that 650 is getting in the way. And the only way to move it over is by dividing both sides by 650. Okay, which 650 divided by 650 cancels out, turns to 1. And on this side, we're left with 325 over 650. Which this will actually reduce down to 1/2, since 650 divided by 2 is 325. So this is half of 650. So this will actually simplify to 1/2. So we have 1/2 equals E times negative K times 25. Okay? All right, so now we must convert this bad boy into a log so we can get something out of our exponent and solve for it. So if you remember, we are going to be using natural log, and it stays on the same side as my base. So it's going to stay on the right-hand side. And then remember, you guys, these two are going to trade places. Okay, so my 1/2 is going to hop inside of my logarithm. All right, and then my negative K times 25 is going to go on the other side. Okay, which negative K times 25, you guys, that's the same thing as negative 25K, if you think about it. So I'm going to write it like that, negative 25K. Because that's like, this is like secretly a negative 1. So it's like negative 1 times K times 25. Well, that's negative 25K. So I'm going to write it like that. It might make it a little bit easier when we solve. Okay, and then from here, we need to solve for K, which currently that negative 25 is getting in the way. So the way we move that bad boy over is by dividing, since it's secretly multiplying. So I'm going to divide both sides by a negative 25. Okay, which the negative 25s will cancel out. So K is all that over there. Okay, all that right here. So we need to type that bad boy in our calculator to get our answer. Okay, let's see here. I'm going to zoom in. All right. So remember, you guys, the natural log key is beside the 4. So you see that ln key, that's our natural log key. So I'm going to finish that bad boy. And a natural logarithm will pop up. Holy hot dog. So we have natural log of 1/2. So 1, you see your 1/2. Okay. So we have 1 divided by 2 is 1/2. And then divided by negative 25. Oh. All right, so this is our k value, which this time we don't have any e's in the mix like we did in example 1. Okay, and remember, we're going to round our k value to 4 decimal places. Remember at the top, it says round k to 4 decimal places. So that will make our k value as accurate as possible. Okay, so when I round this bad boy, let's see. Okay, we're going to round to 4 decimal places, so I'm going to look out to 5. Okay, and since that 2 on the end is not larger than 5, it will not bump up to 7. So my answer is just going to be that 0.0277. Okay, so K is approximately, the little wavy lines are approximately, 0.0277. Yay! Okay, so now that we have found our K value, that's going to help us to actually solve for the problem. So let's take a look. Okay, on this side, you guys, it says use the same n sub 0 value. What's our n sub 0 value? Oh, I'm sorry. This should have said n sub 0, you guys. What am I talking about? This should have been n sub 0, which I did put it in for n sub 0. I just didn't label it as n sub 0. Jeez, you guys, the demon cats get me. So this doesn't mess up our problem. I just incorrectly labeled this as n sub t when I meant n sub 0. So, sorry, you guys. Okay, so n sub 0 is 650, which that's what we used over here. So the same value we're going to use again. Okay, it says use the same k value as the one we just got over here. So we're going to use this k value. So k is 0.0277. That equals our k value. Okay, and we're going to either use the new n of t or the new t value. And once we find that, we'll either solve for n of t or t. Okay, so like if we have an n of t value, we will be solving for t. And if we have a t value, we will be solving for n of t. So we have to figure out what we have and what we're solving for. So let's take a look here. Okay, let's see if I can zoom it out just a little bit more. All right, so let's see here. Determine how long it'll take for 650 milligrams of a sample of chromium-51, which has a half-life of about 25 days. So this half-life time, you guys, we are not using over here, so that's not my T value, so I need to keep looking. To decay to 200 milligrams. Okay, I want to know how long it will take. Okay, so I'm solving for a time, you guys, since I want to know how long it will take. So I'm solving for my t value, and I want to know how long it will take to decay to 200 milligrams. Okay, which that is smaller than my start amount, and since these are decay problems, this is going to be my end amount, which is my n of t. Holy hot dog. Okay, so this is my n of t I'm using on the other side. So n of t on the other side, which if you want to put a little 2 there so you know you're using it on side 2. So now my n of t equals 200. Okay, you guys, let's get to solving, which once we set it up, it will flow just like this one did on this side. So let's get going. So my n of t is 200 equals n sub 0, because we're using this formula. So my n sub 0 is still 650, the same as before, times e is just e, it's not a variable, so e to the negative k, so k is 0.0277, so my negative k will be negative 0.0277, and then times t, because we're solving for t, yay! Okay, let's get to solving, you guys. So, before we do anything, we need to get E on one side by itself, and that 650 is getting in the way. It's irking Miss Long. And since 650 is multiplying to my E, the way we move it to the other side is by dividing both sides by that bad boy. So divide. Okay? Which the 650s will cancel out. Guys, I'm not even going to reduce this down because my calculator can do that for me. I don't need to waste my time with that. Okay? Sorry, guys. So what I currently have is 200 over 650 equals e to the negative 0.0277t. Alright guys, so my t is trapped in the exponent. So the way we get it on one side by itself is converting this thing into into a logarithm. So let's start doing that right now. Okay, so the log is going to stay on the same side as my base. So my base is here, so it's going to stay on the right-hand side, which since I have base e, it's going to remain as my natural log. And then remember, you guys, these two are going to trade places. So my 200 over 650 is going to hop inside of my logarithm, bam, like this. All right, and this negative 0.0277t is going to hop to the other side. All right, guys, we just got to solve for t and crunch some stuff in our calculator, and we'll be done. Okay, so the way we move this negative 0.0277 to the other side is by dividing, since we are secretly multiplying right here. So I'm going to divide both sides by negative 0.0277. Bam. Okay, which it will cancel out on this side. So let's solve for t, which it says round your final answer to 1 decimal place. So let's see what magical things will happen. Okay. All right, let's see if I can zoom in some. Can we see it any better? Yeah. Okay, so we have natural log. So I'm going to put all this into parentheses. So 200 divided by 650, bam. Okay, and then I'm going to say divided by that negative 0.0277. So the time, it says round to 1 decimal place. So I'm going to go out to 2 decimal places. All right, so that 5 will bump up this 5 to a 6. So it'll be 42.6. And before I give it its units, we need to figure out what that will be. So it'll be time will equal 42.6. Now I need to know the units for my time. So let's see here. Okay, this was given to us in days, the half-life time. So my units for time will be days. 42.6 days is how long chromium-51 of 650 milligrams will decay to 200. Isn't that cool, you guys? How exciting. Awesome job, you guys.